In this video, I'll be discussing the topic of black holes are clumps of dark energy. For the first time, observational evidence has been presented in support of the hypothesis that dark energy, which is driving the expansion of the universe, exists inside black holes, garnering significant attention. First, let's briefly explain the background of black holes and dark energy, the main theme of this video. Black holes are celestial bodies with such powerful gravity, due to the extremely high density of the matter they contain, that nothing, including light, can escape from them. Black holes are generally thought to be celestial bodies formed when very massive stars, much heavier than our Sun, reach the end of their lives. Bodies classified as stars, like our Sun, maintain their shape due to a balance between the outward force from nuclear fusion reactions occurring in the core of the star and the inward force of gravity. When a massive star, with a mass more than 8 times that of the Sun, reaches the end of its life, nuclear fusion reactions stop, and the force that counteracts gravity is lost, causing the core of the star to be intensely compressed. In the final moments of a star's life, the immense gravity causes electrons to react with protons within the atomic nucleus, transforming them into neutrons. As a result, the core of the star becomes a structure composed entirely of neutrons. These newly formed neutrons repel each other through a force called degeneracy pressure, which balances against the gravity trying to further compress and merge them, resulting in a stable state. Celestial bodies that maintain their shape in this state, where their own gravity is balanced by the degeneracy pressure of the neutrons, are called neutron stars. If the gravity of a star is so intense that even the degeneracy pressure of the neutrons cannot withstand it, there will be no more force to counteract gravity, and it is believed that compression will continue indefinitely toward a single point. In this way, celestial bodies in which the gravity is so strong that they lose the force to counteract it, and all the mass of the star continues to fall into a single point called a singularity, are referred to as black holes. Ordinary celestial bodies have a force that counteracts their own gravity. For example, in the case of stars mentioned earlier, the expansion force from nuclear fusion, or even for ultradense neutron stars, the degeneracy pressure between the neutrons counteracts their immense gravity. However, black holes are unique among all celestial bodies in that they do not have a force to counteract gravity and instead experience eternal compression toward the singularity. Dark energy, on the other hand, is an unknown energy that, contrary to the gravity of matter trying to contract the universe, is causing the universe to expand at an accelerating rate. Initially, it was believed that the driving force behind the expansion of the universe was solely due to the initial push from the inflation that occurred at the moment of the universe's birth, with no subsequent force accelerating the expansion. This idea is similar to when you throw a ball straight up into the air on Earth. When the ball is thrown straight up, Earth's gravity pulls it back, causing it to decelerate and eventually fall back down. Similarly, it is natural to assume that the universe was given an initial velocity in the direction of expansion at its birth, but due to the gravity of matter, the expansion speed would gradually decelerate and eventually contract. Of course, just as it is unthinkable that the upward velocity of a ball thrown straight up would accelerate due to some unknown force, it is also difficult to imagine that the expansion of the universe, which is being pulled by the gravity of matter, would accelerate. However, in the 1990s, it was discovered that such a strange phenomenon was actually occurring in reality. In other words, the expansion of the universe was accelerating. The source of this mysterious force that accelerates the expansion of the universe against gravity is called dark energy. Because it accelerates the expansion of the universe against gravity, it has more energy than all the matter in the universe. Even now, the true nature of dark energy remains completely unknown, but there is a theory that dark energy is a property of space itself, and that as the expansion of the universe increases space, dark energy also increases. In fact, there has been a bold hypothesis that black holes are clumps of dark energy. If this is true, there is a possibility that it could solve two major problems in modern cosmology at once: the origin of dark energy and the existence of black hole singularities. We don't yet know much about the origin of dark energy, but if black holes are clumps of dark energy, they could be a potential source of dark energy. In other words, as black holes grow, dark energy increases, leading to the expansion of the universe. Conversely, as the universe expands and dark energy increases, black holes, which are clumps of dark energy, also grow. There may be a complementary connection between the expansion of the universe and the growth of black holes, where if one occurs, the other also occurs. If black holes are indeed clumps of dark energy, this would also solve the problem of black hole singularities. Singularity is a troublesome concept in which various parameters, such as the density of matter and gravity, diverge to infinity, causing the breakdown of physical theories. As mentioned earlier, it would be preferable if singularities did not exist. If black holes are indeed clumps of dark energy, there would be no need for singularities to exist in them. As previously explained, typical celestial bodies other than black holes have some form of counteracting force against their own gravity, allowing them to maintain their shape. In the case of black holes, there is no force to counteract gravity, so a singularity exists where matter falls infinitely into a single point. However, if black holes are clumps of dark energy acts as a counteracting force against gravity. As a result, such black holes can also solve the major issue of the existence of singularities. Furthermore, this hypothesis can solve two major problems, the origin of dark energy and the existence of singularities, without adding new concepts, by simply connecting the existing concepts of black holes and dark energy, making it groundbreaking. With this background, an international research team, including the University of Hawaii, announced just recently that they have discovered the first observational evidence supporting the hypothesis that black holes are clumps of dark energy. The observational evidence is the existence of supermassive black holes growing through an unknown process. The research team focused on black holes located at the center of massive elliptical galaxies. According to the general understanding, black holes grow by absorbing surrounding gas and dust, or by merging with other black holes. However, these elliptical galaxies were formed in the early universe, with star formation ending early on and no gas remaining. Therefore, it is believed that the black holes at the center of elliptical galaxies lost their growth material early on and stopped growing. The research team observed three groups of elliptical galaxies from about 2 billion, 7 billion, and 9 billion years ago, and calculated the mass of the black holes at their centers based on observational data. The black holes at the center of elliptical galaxies should have stopped growing, and there should be no change in their mass regardless of which era of elliptical galaxies are observed. However, the mass of black holes was found to be significantly smaller the further back in time the elliptical galaxies were observed. Specifically, the black holes grew about 7 times between 9 billion and 7 billion years ago, and a staggering 20 times between 9 billion and 2 billion years ago. The significant growth of black holes observed in elliptical galaxies, which should have exhausted their growth material, cannot be explained by traditional theories alone, suggesting that they are growing through some unknown process. As previously mentioned, if black holes are clumps of dark energy, they could potentially grow in conjunction with the expansion of the universe. With this possibility in mind, the research team further quantified the relationship between the expansion of the universe and the growth of black holes. This is evaluated by a constant called k. If the value of k is 0, it indicates that the expansion of the universe and the growth of black holes are unrelated. On the other hand, the larger the value, the more likely it is for black holes to grow substantially along with the expansion of the universe. As a result of the analysis, it was found that the most likely value for k is 3, and it was also shown that the probability of this being zero is almost non-existent. Moreover, the observed facts were in good agreement with the implications of this value for the era when the expansion of the universe accelerated. This result is the first observational evidence suggesting that the true nature of black holes is a clump of dark energy, and that the expansion of the universe and the growth of black holes have a complementary relationship. This discovery could potentially provide a clue to solving the two major mysteries of the accelerated expansion of the universe and the singularity inside black holes. On the other hand, it seems that there is no shortage of skeptical opinions among experts regarding these results. In any case, further detailed research is expected to be conducted in the future, and deeper insights surrounding this theory are anticipated. Thank you for watching this video. Please subscribe to the channel and give it a thumbs up. Let's meet again in the next video. Bye.